Welcome back. This is video 2 in chapter 3, Measures of Central Tendency. Let's go over what our goals are for today. In this video, we are going to work on calculating the median, both manually and using the TI-89. We're also going to look at calculating the mode. You can't do that on the TI-89, so we'll just do that manually. And then we will work on the mid-range, again, both manually and partially on the calculator. And then I want to make sure that you understand the symbolic notations for each of these measures of central tendency. So those are our goals for this video: the median, the mode, and the mid-range. The median is the middle point. So I want you to think of a group of people who are all hanging out together. They happen to be lined up. A bunch of people. They're short and tall. They're various shapes and sizes. Okay, so lots of people, and they're all lined up. And this is our data set. Remember that before we would say that this was X1, the first person in the data set, X2, X3, X4, X5. We'd name each person in these data sets. Think of each number in a set as a measurement of a person or of a thing, of an object. Each number tells us a story about a particular person, thing, or object. And so when we get a group of numbers together, that also tells us a story. It tells us what's going on with this particular group of people, things, or objects. So I have these all labeled, and now I would like to find the median. I want to find the middle point. And maybe the median this time is going to be based on height. So we take this, and the smallest person maybe is this person right here. So that becomes the first person in my set over here. Now, this X6 becomes the first person in my ordered set. So as statisticians, we rename that person as X1 in parentheses. When you see the subscript in parentheses, it means that you are seeing the set ordered. The parentheses means the set has been ordered. Then this X5 now becomes over here and becomes X2. That number. And this guy right here is X3. And then maybe this person here is X4. And then this person right here moves in line over here as X5. And then this person is X6. And I've ordered these all by height. There's X7. And now I want to know, where's the median? Well, the median is the person or the line, the place in the data where half of the numbers fall below that person and half of the data set falls above that person. So you think of the median as a middle point. But really what you think of is 50% of the data is below this, 50% of the data is above this. So if I were to tell you, hey, on a stats test, the median was 87, that means half of the people in class got above an 87, and half of the people in class got below an 87. So it's the 50% mark. That's how you really want to think of it, is the 50% mark. Ooh, big 50%er. The 50 center. All right, so our middle point here, since this is an odd set, our middle point is whatever this number is here. So whatever the height of X4 is, that represents the median point. Okay, let's take a look at a second example for the median. All right, this is the number of tornadoes that have occurred in the United States over an 8-year period, and we're going to find the median for this particular example. All right, so the first thing I need to do is I can't just say, all right, there's 1, 2, 3, 4, 5, 6, 7, 8, so it's even, and I'm going to go half and half. That's not going to work, because in order for you to do this, your set has to be ordered first. That is super important for the median. So I'm going to show you what the procedures are to finding the median. So the first important thing is that you arrange the data values in ascending order from smallest to largest. So go ahead and write that down, because that's the important first step, going from smallest to largest. And then you count how many you have in there, and if it's an odd number, you take the middle value of that odd number, and if it's an even number, then you take the two middle values and divide by 2. So if I reorder this set, my smallest number is 656. So we have 656, then 684, then 702, then 764, then 856, 1132, 1133, and 1303. Okay. I have 8 numbers in the set. These are my two middle numbers. I'm going to average these two numbers. So my median is going to be 764 plus 856 divided by 2. So on my trusty TI 89 calculator, or whatever calculator you have near you, make sure you use your order of operations correctly for this, and you get 810. So the median number of tornadoes in the United States over an 8-year period is 810 tornadoes per year. That means that in half of those 4 years you had more than 810, and in half of those 4 years you had less than 810. I want to take a minute to talk about why the median is so important. The median is a really important statistic because you could have a group of people that has some unusually tall person, and everyone else was about average. So you have all these normal people that are about 6 feet in height. As if that's normal height. That's pretty tall, I guess. But just assume that in this area, they're about 6 feet in height. And then you had this one person who is 10 feet. Okay. What's going to happen with the mean is the mean is going to make this 10-foot person is going to make that mean be a little higher than it should be, when really most of the people are 6 feet height. But when you actually calculate the mean, it's going to come out that this 20 or 10-foot height person is really skewing the results. The median doesn't do that. The median is what is called resistant to outliers, extreme values. So the mean is highly affected by outliers, like it will be pulled in one direction or another based on the outliers, but the median is resistant to these outliers. So notice here, yeah, the mean's going to get pulled up because this guy right over here, his extra height is going to kind of get leveled out with all these folks. But the median is still 6 feet. So even if this guy was 100 feet tall, if that was even possible, the median doesn't change. Still 6 feet. So no matter how tall your tallest guy is, the median's going to stay constant. And that's a really important fact, and that's why the median will be used over and over again in statistics. Okay, now let's take a look at how we're going to do this on the calculator, the TI-89. So just like before with the mean, it is in the same screen as the mean. So just like before, you are going to take your numbers, these guys right here, and you are going to go to the Stats List Editor. So again, that was Apps. It's the Apps button. And then choose Stats List Editor. And then from there, you're going to enter in those numbers as, you're going to enter in these numbers right here into your list 1. So you can clear out your list 1, and then to clear it out, you go all the way up to the top of this here, you hit the clear button, and then you move down, and the numbers will disappear if you have an old list there. So go up to the top, hit clear, move down, the numbers will disappear. Type in your list, and then you're going to choose F4, and then choose one variable stats, and then you're going to make sure that where it says list, it says list 1, and where it says frequency, it does not say list 2. It says the number 1 because each of these things happen one time. You only use list 2 if you're trying to find a grouped mean, like you have a frequency table. You do not have a frequency table here, so you just put your frequency as 1. And then you hit enter. So when you hit enter, you're going to come to a screen the same as the mean screen. The mean will be at the top, and if you hit the down arrow button, you will see the median appears right here. So there's the median. Got the median going right there. Median is 671. So your calculator will calculate the median for you. I also want to point out a couple other important features right now is that you have a minimum here and a maximum. So it gives you the median, the minimum, and the maximum. And the min and max are going to be used for the mid-range, and so that's why I'm pointing it out now for you. Okay, so the next thing we're going to talk about the mode. And the mode is not an overly popular statistic because it's really hard to calculate. And also, it can be really deceiving. I mean, you could have two numbers that are really uncharacteristic of the set, and because they happen to match, then they're your mode. So it's not really a great measure of central tendency unless you have a really consistent kind of a normal set where the mean, median, mode are all the same. Then the mode can be a nice indicator. Mode is often used more for categorical data. You can't really say what's the average color of eyes because obviously what are you going to do? Like add brown and blue together and divide by 2? Doesn't really make sense. But if I say what's the modal class for eyes or which color of eyes happen the most, then that makes sense. So mode is often used for categorical data. So here we're going to talk about this airport parking, and we want to find the mode here. So we're just going to look and see which one of these numbers tends to repeat more than once, if anything. So if I were to take a look at this and start ordering it, I'd have 203, 260, and next smallest is 690, 700, and not 750, 900, 1131, 1479, 1962, 2516, 3400, 5905, 8662, 8662, 9239, 9822. Notice there are no repeats here, so this has no mode. It has no mode. So let's take a look at the modal class. The modal class is simply going to be the class that has the most. So the modal class on this guy right here is, oh, look at that, 21 has the most numbers. So the modal class is from 177 to 185. So that's called the modal class, and you just write the class down, the lower and upper limit. So you just say, what's the modal class? You say the modal class 177 to 185. That's the modal class. It is the one that has the most. The mid-range is a fun one. It is kind of a rule of thumb. So it is kind of a quick, easy estimate for the middle. It's not, again, terribly accurate because you have one outlier and it's way skewed. It doesn't tell you awesome information, so we don't use it a ton, but it is pretty quick to find out how to find it. So you take a look at a set. So we'll use this airport parking data again, and you find the smallest. Nope, not that one. 203. 203. And then you add to it the very largest, which is this guy right here. So we add 203 plus 9,822. And we get 10,025. And then you divide that whole thing by 2. And you get 5,012.5. And that is the mid-range. So again, it is a quick rule of thumb for the center. It's kind of an estimate of the average. But it's not a great estimate, to be frank, but it's called the mid-range. You can use your calculator to find the mid-range. Let's look at these police incidents data one more time. Again, you enter it into your calculator, you do your list 1, you choose your F4 one variable stats, you make sure that it says list 1 and frequency 1, and hit enter. You will recall from before that you get this screen, and you will recall from before that you need to scroll down to find the minimum and the maximum. So you have to hit that down arrow button right here to see the rest of the statistics. So you scroll down and now you see that you got a minimum here of 440 and the maximum here of 1052. Then you have to manually add those together and divide by 2. So there you get 746. So there's not an actual mid-range list on this list that says, oh, there's the mid-range. You still have to do some manual math. All it will do is pick out the minimum and maximum for you. It's not a quick process to use your calculator for the mid-range unless you're already using it for the median and the mean, which the calculator is handy for those two functions specifically. Okay, there are 4 measures of central tendency: the mean, the median, the mode, and the mid-range. So 4 measures of central tendency: mean, median, mode, and mid-range. These are the 4 that you're responsible for. Remember that the mean has 2 different symbolic notations. So if we think of these as for population versus sample. So the mean for the population is the Greek letter mu. For the sample, it's the Roman character x with the bar over it, x bar. That means average. The median, for a population, most books use theta, the Greek letter theta. Our book doesn't really use anything for population median, but this is kind of what the standard is for most statistics. And our book for the sample uses MD for median. Again, Roman characters. The mode, nothing for either. There is no shorthand for mode. If you want to know the mode, you just have to write out mode, M-O-D-E. Your hand shouldn't cramp up too much, you hope. And then finally, the mid-range. There's not really a population mid-range, so there's really nothing for this one either. But for a sample, our book uses MR, so for mid-range. So those are the symbolic notations. The other symbolic notation that I really do have right now is how we list sets. If I give you a set of these numbers, 8, 12, 10, 5, 15, then I would say this is the first one in the set, the second one in the set, the third one in the set, the fourth one in the set, and then the fifth one in the set. Then I reordered the set. So this is 5, 8, 10, 12, 15. Then when I rewrite this, I say this is my first one in my ordered set, second one in my ordered set, third one in my ordered set, fourth one in my ordered set, fifth one in my ordered set. See, these parentheses tell me, as a reader, that someone has taken the time to order the set. So the parentheses in the subscript means ordered set. All right, now let's practice this, our wicked new measures of central tendency skills. And please find the mean, median, and mode, and the mid-range of this data set. Mean, median, mode, and mid-range. Hit pause. Edpuzzle will ask you for the answers. Okay, so now you have completed video 2. Congratulations. You have now completed all of the measures of central tendency that you need. So you have Canvas homework to complete online. And if you would like additional practice questions, check out your Bluman book. And that is in Chapter 3. All right, have a fantastic day. And be safe out there. Ooh, look, this guy's going to have some pretty cool ears. And he loves stats. Loves stats.